Hi everyone, so today we're going to be looking at the quadratic relation. And so we're just going to recall a few things that we discussed yesterday. So the first thing is if a positive parabola, it opens up and it has a minimum because of how it sits. So if it's opening up, this is the minimum. If we have a negative parabola, it opens down and it has a max due to how it sits at the top here. So we're going to look at these following examples. We're going to do A and B together, and you're going to complete C on your own. So which way does these examples of this equation open? We'll have a max or a min. So let's look at A. So in this equation, we have our A right here, which is our 3x squared. And this is positive. So because it is positive, that means it opens up, and therefore it has a minimum. For B, in this equation, it is negative. So we're always looking at the x squared. And so because it is negative, that means it opens down, and it's going to have a max. And then last but not least, we have C, and I want you to try that now, see what happens. Is it positive or negative? Take a look. So it opens up, and therefore it's a minimum. So notice all the above equations were in the form of y equals ax squared. Obviously, right below it is plus bx plus c, but notice that they put b is equal to 0. So let's investigate this form. So in this situation, y equals 3x squared. So that means it's gonna be plus 0. So therefore, because it's positive, it's gonna have a minimum. And the intercept of that is going to be 0 because it's not labeled, but because it's not labeled, we always assume it is 0. And if we were to graph this out, it would start at 0 of our y-intercept, and our vertex would always be at 0 and 0 because of our c value. And the max min value, that is what we're looking at here. This is our y-coordinate of vertex. So this point right here, that means it is a 0. So our min value is going to be 0. Now the next part, we have our x squared. Same thing as positive, so we have a min. We have -4, so that is our c-intercept. If we were to graph that, we have to go to 4, and then just graph our parabola. So therefore, our vertex is going to be 0 because it starts at 0 and 4. Sorry, -4 because it's negative. And therefore, our y-coordinate is a minimum value at -4. Now, last one here, we have a -2, so that means it's a max. Our y-intercept, which is our c, is 3. It's +3. So therefore, we start at +3. It's a max, so it's going to go down. And then our vertex starts at 0 and 3. And our y-intercept is a max value now of 3. So all of that can just show us that the equation, we can solve what the max min is based off of our information. So we can also write a quadratic relation in the form y equals ax squared plus c, which b is equal to 0. So A tells you the direction of opening, and therefore whether it is going to be a max or a min value, and then the c tells you the y-intercept of it, and if it's also going to have a max or min. Okay, so the vertex, remember, it's always with 0 and c, because b is also 0. So when we are looking at this, let's look at an example below. It says find the maximum or minimum value of each relation. So this is looking at the y-intercept, which is also our c. Okay, so we have y equals 2x squared plus 0 because we know there's nothing there, so it's always going to be 0. So therefore, it's going to have a min value because it's positive, and our min value is going to be 0. And its vertex, because that is 0, it's going to be 0 and 0. Next one, we have positive, so it's a min value of that, okay? It's also going to be a min value of -9 due to our y. So therefore, our vertex is 0 and -9. Try C out. Is it going to be a min or max? Pause now. So this situation will have a max because it's a negative. It's going to have a max of 7. So therefore, our vertex is 0 and 7. All right, let's do this example together. So we have the following relation. So this is in the same format as y equals ax squared plus c. So is it a max or a min? So in this situation, we know it is a positive 0 from our positive x, same thing, or positive 1, sorry. So that means it's going to be a min because it's positive, and the minimal value is right here, -25. And then the vertex is going to be 0 and -25. Then it's going to say, oh, sorry, it said what is the min. Then we have what is the max or min. So because of the situation here, because it is opening up and we have our positive here, that means it's going to be a min value since it opens up. Okay, because A is positive, therefore it opens up. Now for C, what is the 0? So C is always our x, zeros is always our x-intercepts. So therefore we need to look for our R and our S. And we learned about that yesterday. So in order to do that, we have to go from standard form to factored form. So it's going to be y equals x squared minus 25. And we need to find what is the square root of each of these in order to solve. So the square root of x squared is going to be x. The square root of 25 is going to be 5. And you're like, Miss, but this is a -25. We cannot square root negatives. So we have to keep it positive, and we'll worry about the negative afterwards. So we are left with x plus 5, and because it's negative, we're going to keep an x minus 5. And so our R is going to be equal to -5, and our S is going to be equal to +5. So therefore, we have -5 and 0, and then we also have 5 and 0. Therefore, those are our zeros. Now we can sketch, so -5 and 0, and then 5 and 0. Our vertex we know is -25 and 0, so therefore we can draw our parabola based off of this. Now, try to fill out the following table. We're going to do A and B together. C, you're going to try it on your own. Ignore these question marks. That's an equal sign. So, based off this, what is the y-intercept? That is always our C, so that means it's 5. Our minimum is it a max or minimum? It is a minimum because it is positive, and that is going to be 5. Same thing here, we have a negative, so that means it's going to be in the max, and the max is whatever our C is, which is 27, and our y-intercept is also 27. Pause now, try out C, solve, what is it? All right, we have a y-intercept of -1. It's going to be a minimum because this is a positive 1/4. All righty, now let's try out this part right here. All righty, so it says the path of a stone after slightly tossed from a cliff can be modeled by the relation. So this is our relation here. So that is always in the form of y equals ax squared plus c, where h represents the height of the rock in meters and t represents the time. So will this relation have a minimum or maximum value? So looking at this equation, we can see it's a negative, so that means it's going to have a max value. And then the max value is going to be obviously 64. So it opens down. And that is because A is negative. What is the height of the rock thrown? So that is our y-intercept, which is our C. So therefore, rock was thrown at 64-meter cliff due to what our C value was. What is the maximum height of the rock? So that is also the y-intercept. So the max height is 64 meters. And then it says it's lightly dropped, not thrown into the air at first. Okay? So it's lightly tossed. So because of that, that's why. And then how long does the rock take to reach the ground? This is where we have to find our x-intercepts, which are our zeros. And we have to do this, we have to put into factored form. So therefore, we have h equals -4t squared plus 64. Let's factor this out. So our greatest common factor here is 4, and that is a -4 because we want to get rid of that, so divide by -4. We are left with a -4 on the outside, t squared minus 16. Okay, and then from there, that's when we can divide out both of these. So when we divide both these out, we are left with -4. We have t plus 4 and t minus 4. So therefore, our r is going to be -4 and our s is going to be 4. So therefore, since you can't have a negative time, okay, we can't use a negative time, can't use that. Therefore, we disregard that -4, so therefore the rock will hit the ground at 4 seconds. Okay, so please make sure you understand that because it's negative, we can't use that. We can only use positive, and that's why we can't have negative parabolas. So narrow, wider graphs, the greater the value of A, the skinnier or narrow the parabola is, the smaller the value, the wider it is. So disregard the sign when comparing the values, just look at the number, okay? So in this situation, we have 4, which is our A. So therefore, for comparing 4 and 3 together, we can see what one has the greater value. We're comparing the numbers. So since 3 is smaller than 4, that means the greater the value, so 3 is smaller than 4, our y equals 3x squared minus 7 is going to be wider. Okay, so let's compare these two together. Let's compare our numbers. So we have 2 and 4. So this one's going to be wider, and this one's skinnier. Same thing, we have -1/3 and -1/2. So if we're putting this into decimal, that means this would be 0.33, and that this one would be 0.2 or 0.5, and both these are negative. So that means the 0.33 is less than 0.5. So that means this one's wider and this one's skinnier. All right, so practice your homework now. There's also a practice sheet at the bottom here. If you have any questions, let me know.